Okay, question 13. We are almost finished with this worksheet, which I am recording in one go, so I am kind of very bored right now. State the balanced chemical equation for the formation of the following polymers. The first one is polyethylene, which shows that the monomer must be ethene. Okay. The way to write a formation of a polymer, so you want to start with the monomer. This is okay. This is not great, but I will live with that. Once again, and if you just listen to question 12, I just said this, you want to make sure that when you write a polymer, and you don't have to do this for the monomer, but it's a good idea, is only the CC double bond is in the backbone in the main chain, and everything else is lifted either up or down, because that's how it's going to look in the polymer. You also want to write N at the start, just to indicate that you have many of the monomer and not just one. And many of these reacted together is going to give you the polymer. Now the question doesn't indicate what form of the polymer to show, but if you want it to be balanced, one way is to, not sure what just happened there, is to do this. So you want to show that you have this structure which will keep on repeating multiple times. So you do a bracket around it. You need to make sure that the line goes out of the bracket, and then you put an N here. So it's to indicate that this particular section will repeat N times. Now if I need to draw a section, this is the formula basically, but if I need to draw a section, then draw a section. So H, 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 this is one monomer, and this is another one. And you probably want to do dot 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 just to clearly indicate that it's going to continue. I don't know why it does this. I think it means something, I don't know. Anyway, there's that. That's part A. Polypropene, part B. Okay, so when you have something a little bit more complicated than ethene, then you will see that it's actually a very good idea to start with the double bond as the backbone. So if I just draw the structure of propene here, you have 3 carbon. Now, I mean, obviously the double bond has to be somewhere here. And I have 2 hydrogen here, 1 here, and 3 here. So when I set the monomer up to form a polymer, I am going to focus on the double bond. So the double bond is my is in the main chain. The question doesn't indicate a particular form of formula, so I'm not gonna go with structure because it's a little bit annoying. But this carbon, which is the first one, is going to have 1 hydrogen up, 1 hydrogen down. So anything that is not the double bond, I will either move up or down. This carbon has a hydrogen here, and the CH3, I'm going to write it down here and treat it as a branch, because really when you have the addition polymerization, it becomes a branch. So you put an N here, and with the product, okay, I'm going to do a section underneath first before I show you the actual formula. So C, so the double bond will break. You have a H, a H, a H, and then a CH3, and then this is going to link with another monomer. You don't need to be too concerned with the location of the CH3, because in reality, you know, there are multiple ways that you can form these polypropene. So you can control it so that they on the same side, or the CH3, or that they're going to be on alternative sides, or they random. So you really don't need to have a very specific order. As long as you have a CH3 you know, for every monomer, you should be okay. So this section can be translated to this as the formula. So we're just gonna show that we basically have this being repeated n times like that, and that's fine. Chloroethene, polychloroethene. So hopefully once you get better, you don't need to draw this on the side. But if you're not sure, you can always just draw it out and then move it up so that you have the CC double bond being the main chain and everything is moved. Now because it said chloro, it means just one chlorine, and then the rest has to be hydrogen. So I will have N as well. And all I need to do is to break that's wrong. All I need to do is to break the double bond, and then I will literally just have this monomer being repeated throughout the entire polymer. This is not a very difficult case, I think. So there you go. Okay, that's 13.